started. We are still working on lecture number 1, but it's 160 something slides. So let's finish it today. And I know I'm not going to start from number 1. I'm going to try and go to a spot where I think that we slide number 64. But on the way there, let me just acclimate into the subject because it's really weird to start a lecture in the middle. So we were talking about the object-oriented features of Objective-C and how it works and how it differs from C++ and how it's very similar to Smalltalk. If you don't know Smalltalk, you can probably learn Smalltalk quite easily after this course. Smalltalk really isn't taught very much lately because it's kind of an old language that's not really used very much anymore. It doesn't work very well for internet development. It doesn't have a place like iPhone applications or anything, or Coca development, where Objective-C is a little bit more popular because you know, of modern day technologies and platforms. We were talking about inheritance and polymorphism and variables and class objects, and I'm going to hit a little bit about memory today as well with alloc and refresh your memory on that, so I'm going to skip that for a few. Defining classes with the .h's and the .m's, and last time we actually looked at examples of how to define classes. We looked at like 3 or 4 different classes. We looked also at the methods. The plus is for a class method, the minus is for an instance method, and then the declarations as well, using the import instead of the include. And then at the @class directive for rectangle and circle to define the class in terms of referring to other classes. So if the interface mentions classes not in the hierarchy, it can use an @class to refer to a class that's outside of the hierarchy. I wanted to use it that way. And we looked at the implementation examples of a worker and production worker, and I showed you employee and person. We looked at compiling on a command line prompt, and we ran hello world, and we ran it in the, we looked at strings, string objects, and we did some interface, looked at some interfaces, actually talked about property and synchronize as well. And how far did we get here? We continued, we looked at how to pass messages. So we have the receiver object along with the message that's been sent to the receiver. And then we looked at things such as a semicolon for variables, for passing arguments along with them. So let's see. There's no example of that on here, but I've shown you some examples already. Alloc and init. We looked at the init concept. It should be applied to an instance before it's being used, and we looked at the syntax for running alloc as a method on student object and running init on the object that's created from the alloc on the student. So hopefully that's familiar-ish. Let's see. We also looked at reference counting, and we stopped around here, I think, didn't we? Did we cover data structures? Yeah, I think we stopped. I want to say we stopped around here-ish. Yeah. Okay, good. Data structures. Data structures. Let's just talk about data for a second. We have objects, and then we have built-in data types. Objects are using string, like NSString, as we were talking about before the class started, is a reference type, referencing to an object. And so actually string is an object in C++ as well. In Objective-C, however, we use an asterisk pointer indication with the object references to say NSString space asterisk my name or something, or the name of the string that you're creating. And then after that we just go and use name. So the syntax is slightly different because we're making a reference object to it. So it's really a pointer object. And all of the built-in objects, the predefined objects in the base libraries use references. I use pointers. These don't. They don't have to use it. They're just like C. Because they're not objects, they're built-in data types. So in some of the examples I showed you last time, we had integer. It was like integer I. You know, it looks the same in Objective-C as it does in C, actually. So Objective-C arrays are the same as C arrays, but you can initialize the whole array in a list. So, or you can just use a few indices in the array, and the rest are set to 0 or mixed and matched. This is actually the same as C. C will automatically set them to 0, and you can actually take and initialize the entire array, and it will actually automatically figure out what size it's supposed to be. So all of these little tricks actually work in C as well. So here's some examples here of an array if you have never seen an array before. It comes in very handy. A couple of the assignments are going to have you use arrays, arrays of objects, which are going to work the same way. But the structure itself is not a pointer, but you might be putting pointer objects or references inside of it. So arrays can hold everything. Numbers, pointers, anything. So here we have values 3 that equal value 3. Initializing. We're using the opening and the closing curly brackets here. And then we're using the solid brackets over here to indicate the sizes, the size of the array. Character array 3, and we have characters in here separated. Or the character notation is the same as C, using a single quote. Strings use the double quotes, the two of them together. Grades 100. This is grades float, so we're using a decimal here. And then we have an array of, well, we have 13. 3 is 11, 2 is 1. 7 is 0. This cannot be done. This cannot be done in C. This is more small talk, like, where we would have to do this outside of the initialization. It's possible, but we would do it, we'd create the integer array, and then we would go array indices 0 or 3 is equal to, well, here we've got 3 is equal to 11, and 2 is equal to 1, and 7 is equal to 0. I mean, we would do them separate lines. But, so this is a shortcut method that you can do in Objective-C. Objective-C also supports multi-dimensional arrays, so it can be initialized by using a subset notation with brackets. Note the no comma after the second subset. So we don't have a comma here at the end. This is where the note was supposed to be. So the subset brackets or braces are optional. And the compiler will fill in the blanks where it can as it does with a one-dimensional array. So if you don't put it in, it'll just fill it in. So if you only put one of them in, the rest of them will be zeros. So in this particular case, we have a two-dimensional array here, and this would be the same as C. This would be the row, this would be the column. And think of this more like a grid or a spreadsheet almost, and then with just one row and one column. And so the zeros are going to be filled in for the column. So the first one is just the rows that would be assigned. And that's actually the same as in C as well. The same thing will work. So arrays and functions. So arrays can be passed as arguments to functions, and in C it's actually kind of interesting because they have some interesting side effects. Because arrays are implemented in the form of a pointer reference in C, but it's passed by value. And it gets treated like a pass by reference. So the function will print, in this particular example, we have this function here. It's going to print every integer in an array, but it needs also to be told how long the array is. So we normally, in this same syntax we get in C. In fact, this is very C-like, except for the printf down here. We have an anislog instead for Objective-C. But in essence, what we're doing is we're creating the function call with 2 parameters instead of 1. So we send the array to it, and we send also the length of the array. There's different ways of making the arrays grow, but this is the traditional C-type array. And so we can actually make an object instead, because objects are all dynamic. And then we can bypass all of the array problems. And I'll show those later on, actually, with some more examples. But for the basic concept, in terms of passing arrays to a function, the statements are hard-coded indices, such as the array 4 are potentially dangerous. This is very dangerous, is what this code is basically saying, because you don't necessarily know what's going to be at element number 4. It might be something else. But here we have a loop inside of a function, and the function is just called, and this is really bad because you wouldn't call the function because that would actually, probably come up with an error message. Actually, who knows? Maybe not. I don't know if the function is a reserved word or not, but it might be. It's a bad name. It's not very descriptive either, is what the function is doing. But it's taking on the array length. So the fourth value is going to be the array 4. And then if I is equal to 0, I is less than the array length, I plus plus, then print out. So nnslog, print out the array items, essentially. And this is using the same syntax as we've seen in the printf with the $i here in terms of printing things out. So with the array item, and this is going to come out as an integer, and we have an integer expression here. So it's really called a format expression that's being used. So, and we know NSLog is the log console, I hope at this point. So, So we have structures, and we looked at structures in our C to Objective-C lecture, but just to review the concept, similar to the Objective-C structure, can be initialized in one go. At one time you can initialize it and use it. So you can use the dot member notation or just use the values in the correct order, or use some unknown values. So in the following example, it's going to be explicitly defined the last member, but the others are undefined. So here's an example. So we have we actually have a couple of structures here. Structure student. Student has BS years, PhD years, another integer, 3 integers in here, well spent years. Then we have a semicolon at the end of the line. And then we have the next structure, my career, that has going to be which is inside, it's my structure student space my career, which is what we got now as a compound. So it's a student type. It's a structure of a student type, but it's my career is the name of the structure. And we're going inside here. We're leaving out because we don't actually have a dot anything. I mean, we have a dot because we're going inside of the students. We're going to put BS years dot, is equal to 3. So we're creating an instance of it essentially, or initializing, the PhD years is 3, well spent is equal to 3. So if we use it down here, we can say student poor life decisions, and we can add it in numbers, which is kind of a slightly different way of defining the structure. Or we can say student structure unknown is 3, and student structure student, any furthermore dot well spent years is equal to 0. So it'll automatically populate the values for the 3 data members that are part of the structure that's associated with it. It comes in handy when you're trying to want to organize liked data of, usually it's mixed match data types. Here we've got 3 integers in here. This could have been an array, actually. But the structure in the dot notation is very class and object-like, I should say. So it's a little bit more descriptive, when you're setting values. But this takes away from the descriptiveness, actually, because we're just setting 3 values. And it's just showing you a couple of different examples of what could be done. You may never use a structure for anything. In fact, a lot of C++ people don't use structures, or unions, or anything else, actually. They use classes. So structures existed before the class came around. And now people use it for holding data, complex data. And complex data is just any data that has more than one element to it. So it's a name, an age, a telephone number, an address, and you're going to call that, student or something, or puts a label on a bunch of small data members. Instead of holding like 12 different variables in the program, you have 1. So simplifies it. So Declare+Define a structure all in one. So similar to the older C style notation, and this is from the beginning of C, actually, some of the older versions. So the example will declare a coffee order structure and immediately define an instance called complexity group. So here we have the structure coffee order and 2 integers inside of it, and then right after here, before we put the semicolon in here, we put complexity group, which is of type coffee order, equals 7, 4. So we populated plain with 7 and double espresso with 4. So it's basically doing an initial, defining one and declaring one all in one shot instead of doing it in 2 separate lines. I don't know if I would do this, actually. I would declare the structure, and then I would just make the instances of that. Use the structure. So, but this is a little shortcut.
You can give int plain is equal to 4, 7 something.
Int plain is one of the members of the structure, and it is an integer value.
Initialize there itself?
No, you wouldn't want to, because each instance is going to hold its own values for it, and that's why you're creating it. So if you initialized it in the structure, you can set it to 0 or something, and then you can always change it. So you can set the default. Yeah, it's like doing a declaration of it out here, and then you initialize it and give it a value in the code when you make the instance. And you're using structure like a data type. It's like integer, float, or anything else, actually, or any class. So. Fitting into limited memory, we have little bit fields. So to work on devices with memory limitations, we Why do we have to worry about that? Because Objective-C is used for mobile devices. It's used for iPhones. It's used for all sorts of different little projects for embedded hardware and stuff. Java and Objective-C actually, and also C as well. So C supports a lot of embedded systems kind of development environments as well when we have to be conservative and we're talking about translating things. So in terms of to work on devices with memory limitations, we manually define the size of variables. So we can say, you know, a byte this or something, you know, and make it as small as possible. When using a structure, all of the members are packed together for efficiency. So it's sequentially spaced out in terms of the memory layout. Next example divides a 16-bit unsigned integer into 3 on and off bit flags and a 10-bit number and a 3-bit number. Note that it is a valid use of the Boolean operations on a single bit variable. And here's what it's doing. Don't worry about what it's doing actually. Just know that you've got unsigned, which is giving you a smaller integer versus the signed. If you leave out the word unsigned completely, it gives you a signed. Unsigned, so we'll just leave out half the number line, and that makes it smaller, gives you a smaller space. And then in terms of the structure, it's the same structure format that we've seen before. So lab.alarm door, lab. We're just setting the values down here. So fitting into limited memory, we can also use a union. So a structure and a union are pretty much the same concept, except for the union only has one piece of data at a time. So if we have a structure that has 5 variables inside of it, every time we make an instance of a variable that is of a structure type, we're going to get space for 5 variables. What if we don't need 5 variables? We only need 1. Why would you do that? Well, that was how polymorphism was actually created before C++. So in the C language, we could have something called weight, and then the weight can be represented in pounds and ounces, in fractions of something. And so you could create a union, call it weight, and then have in there integers, floats, doubles, whatever you wanted actually. And then when the user, did my new weight, or whatever, whatever memory was associated with the union in terms of its label, and set it to something, it would only save space for that whatever it was set for. So it doesn't reserve memory for all of those other options. So it only holds one piece of data at a time. So unions and data structures allow ambiguity. Well, ambiguity was like sort of the predecessor to polymorphism, if you think about it. It's like, is it an object? What kind of object is that? Is it a person? Is it an employee? Well, it depends on how you treat it. So then you can warp the, make an object ambiguous in terms of multiple forms, which is really what that's referring to. Useful for allowing one storage area to hold different variable types. Can only hold one of the variables at a time and must be careful to ensure that the retrievable type matches at least at the last type that was stored. So if you're using a float, you're retrieving it as a float. You're using it as a float. Otherwise, if you try to use it as something else, you're going to get a type error. It's going to be the wrong type. And might come in handy for storing lists of data that might be different types. And the next example gives us one potential practical use. A series of recordings stored data. So recordings are going to be storing data, and the structure has a clear, it's a character, to indicate the type of the data recorded in the data. So here's our example of the union. So we have union, one of the following: character, letter, or float. So the union is called one of the following, and at any one moment of time it's going to carry one of these 3 values, and the values are going to be a character, integer, or float. So if we do one of the following last space on the phone, this is the name of the variable that we're creating, and we go last space on the phone dot letter is equal to a, last space on the phone dot count of is equal to 1. We see count of is an integer, so we're allowed to assign it a number, and then letter is a character, so we're assigning it a character, and then so that's how we can assign. And then at any one moment of time, they're both one of the following union type, so they're both of the same union type. So they're just storing different values at different times.
Can we only one character, one integer, and one? Can we give like
not simultaneously.
2 integers,
It's only going to store one value. Yeah. So when we do this, we change the value. So the letter's not going to be there anymore. So we have to remember what was the last one we used. So the last one here was a count, so it's going to be an integer. So because we assigned it 1. So here's another one called recorded data. And we have a character pointer name, and then we have a union stored inside of the structure. And inside of the union, we have a float, an integer, a character. And then we have data, immediately defined, an instance, which is data is basically going to be an instance that's immediately defined right after the declaration of the structure. So then we can, in the few next lines of code, which is not on here, oh, here it is, actually. No, it's not on here. We could say data, dot, real number, or something like that, depending upon what we're assigning equals something. So we have a character of the type of record, and then we have an array of records, 100, array of record data, which is the record data. So this is just basically showing an example of nesting a union inside of a structure and defining variables of both of them, actually, inside of the union and also right along with the union and also along with the structure declaration. So it makes it more confusing, I think, to look at. But it's a little bit clearer when you write it out, I think. So memory management. Alright, so memory management in Objective-C is semi-automatic. It's even more automatic now with the reference counting. But the programmer must allocate memory for objects either using explicitly alloc or indirectly using a constructor. So you got choices, and now that we've seen constructors or initializers, one of the reasons why people like to use the initializers is because then you can allocate inside of them and not have to use alloc way out in main, out in the driver program. There's no need to deallocate when you allocate, which is kind of interesting. So what is it? Actually, now that we've seen this implemented a little bit, I'm going to talk a little more about what it is you're actually doing. So in terms of the allocation, we don't have to deallocate, we just remove it, we release it. Or we retain something and don't deallocate it. Because the deallocation, this is why it's called semi-automatic. The deallocation actually happens first automatically. The allocation doesn't. So we have to allocate. So allocation happens when the class method alloc is used. So whenever we're running alloc as a class method on an object, we're allocating it, regardless of what kind of object it is. It's not something you're writing either. It's an automatic method that belongs to object, and object is inherited because we're going, new class colon NS object, and so we're actually inheriting from NS object, which means we get alloc in with everything. So alloc is a set of classes of the requested object. Alloc is inherited from NS object. Every alloc creates a new instance, which is going to be equal to the object. So if I showed you this line of code here and asked you what this was doing, this is actually creating the new instance. So this is like saying new hello world in Java, or actually in C++. So, but because of this method format that we're using in Objective-C, we go hello world space alloc, run the method alloc. So then the class creates an object with all zeros in it and returns a pointer to it. So this returns a pointer. Always returns a pointer. So objects are always pointers. And a pointer is nothing more than a reference. And it's just that in C, in C++, and in Objective-C, we use this asterisk symbol. In Java, we never had to. So you just have to get used to the fact that you actually explicitly have to call it a pointer, even though it is a pointer. In Java, this would be hello p is equal to new hello world, and we go, okay, no, fine, because new hello world is going to return a pointer to it. New allocates. We can actually use new hello world with in C, or actually, yeah, in C++, I should say. We could use the same kind of thing here. We can say hello world pointer p is equal to new hello world, and that would work actually. Changing the method syntax around to the C++ style, and that would work just fine. Because this new creates a memory address, and it has to be referenced by something. So the asterisk actually creates the reference object for us. So, and in Java we call it a reference object. We just never use the pointer symbol. I never really identified it that way. But it's really a pointer. So the pointer P now points to the new instance that was created. Now we send the messages to the instance through P. There's no dereference. So if you're a C++ programmer or a C programmer, you go reference and dereference. Well, we're Java, or Java we don't use anything at all, but we're Objective-C, so we're semi-automatic. So we go reference, no cleanup, and then okay, reference, but no dereference. Instead, it says automatically referenced without the asterisk. And we have looked at reference counting in terms of the feature in Xcode now that does, we can check and say automatic reference counting. And we've been using this because we seriously don't want to write this stuff in the code. And we haven't been writing this stuff in all the examples. And when you create your programs, I highly encourage you to check that box that says ARC, automatic reference counting. Because then you won't have to do any of this either. But if you're looking at examples and you load them in and you have automatic reference counting selected, and the reference, your code is using a retain and a release and stuff like that, you're going to have problems. You have to take that out of the code because it's not going to work. Because you get a couple of bad warning messages and perhaps an error message that says, unnecessary. And so you just remove the line of code and it works. So every instance has a so-called reference counter associated with it. Counts how many references are retained by the object. The counter is 1 after the allocation. This is a reference to the object. It's going to be 1. P's around. That's just 1 because P created the object. So that's where we get our first count from. It does not count how many references exist to the object. So it doesn't count how many references exist, but it counts how many objects were created. So the number of references are retained by the object itself. So sending a retain message to the object increases the reference counter by 1. Does that mean somebody's using it? So it's not how many references exist to the object, it's whether or not there's a reference. So what we're really doing is working with a Boolean value that keeps going from 0 to 1 to 2 to back to 1 to 0, or not really Boolean, I guess multi-valued. And it means there's a reference. There's a reference. So sending the retain increments it to 1, sending a release message decrements it. So we retain to say we want to keep it, and we release to say, okay, we released it, but just because we released it doesn't mean everybody else released it. And who are we? Well, we might be in a function, we might be in a section of the code that was reached that's no longer in scope anymore. So we're going to release, hopefully. Because if we're retaining and we're not even in scope anymore, what are we holding on to that object for? So
if we create 2 objects,
mm-hmm.
then we have to release twice.
Yeah. Each object itself, when you initialize it, when you run alloc on it, it starts the reference counter automatically. You don't have to start this either. It's automatically set for you. And automatic reference counting takes all this stuff away. So if you're using automatic reference counting, you never have to use retain or release because you're not counting. Retain or release just keeps things available or makes things go away in terms of the count value. Because everything that's 0 can be cleaned up. It doesn't necessarily exist, or there's no references to it. Which is how garbage collection works, actually. But there's no automatic garbage collection. We're doing our own. We're manually retaining and we're manually releasing. So reference counter equals retain counter. So the reference counter reaches 0, the object is automatically deallocated. So we don't actually have to deallocate it. If we want to deallocate, we can. But if we're keeping the reference for it, and it's zeroed, no longer being used, it's going to automatically be deallocated for us. But if we don't retain and release and go through the whole reference counting concept, nothing will ever be released, or nothing will ever be deallocated, because it will always, every time you create a reference to an object, you increment it by 1, which means your garbage collection is not going to work, which was a huge problem actually for bigger programs. Small stuff like Hello World is going to run just fine. So now when you do Hello World *P equals Hello World alloc and you selected that ARC button that said hey, automatic reference count for me, it's going to deallocate it when it should. So that it actually turns on sort of pseudo automatic garbage collection for you, because it'll deallocate automatically. You just allocate. You don't have to deallocate.
If you don't use anything, it doesn't show any error like we did there.
It's not going to show any errors at all. What's going to happen is kind of like using pointers in C. Something you're going to do is going to mess up something else. And maybe the 5th time you run the program, you'll see it. Sometimes you won't see a problem at all, actually. It'll work just fine. And then you release it, and then all of a sudden, hey, how come it keeps crashing? And then it just starts doing, it's really unpredictable what's going to happen with that. The theory is you run out of memory. If you allocate with not ever deallocating, the longer your program runs, and if you think about how long iPhone programs run sometimes, and stuff like that, or even programs on your computer, the longer it runs, the more it's going to probably crash eventually, because it's going to run out of memory eventually. So the program does not deallocate, the system does. We just keep track of whether we're retaining or releasing. So we're not really deallocating, but we can tell the compiler, or we can tell the system to deallocate. We can tell it to do it manually, but we're not doing it. It's if we're doing the reference counting. So the programmer only does alloc, retain, and release, essentially. There is a dealloc. There's a dealloc method that we can do to manually deallocate it, but we don't actually have to. So rules for memory management. The method that does an alloc or a retain must also do a release. It usually works in pairs. So if you're going to retain it, you're going to release it. Otherwise, it's just like if you didn't keep track of the reference counting at all, because then you're still going to have the same problem. Must maintain a balance. Alloc or retain and then release. So if you're retaining, it's kind of like doing an alloc. You're retaining it. It means don't go get rid of it. I need it for something else. So you've got the memory allocated. You're just going to use a different reference to it. If a method does an alloc and then returns a pointer to the created object, then the method must do an auto-release. So if a method does an alloc and then returns a pointer to the created object, isn't that what we just did? Hello world pointer P, pointer reference variable P equals hello world alloc. So that's a case in which we need to do an auto-release. So then the method must do an auto-release instead of a release. The calling code can do a retain release, but this is not a must. You can do a retain on it and then a release, but this is the auto-release. So it's just a kind of a little, it's an auto. So we have auto-release pool, which automates it. Which you could run auto-release instead of release, but what I'm trying to do is kind of explain the reason why this came about, or what it's used for. So for auto-release to work, yeah?
Does it depend upon the length of the program? Like
Nope.
we used to use auto-release and then we used to use.
Nope. It's doesn't matter. As long if you created a reference to that object, you just have to auto-release it instead of releasing it. Versus, because the reference itself isn't going to do it. So the auto-release to work for the programmer must create an auto-release pool. So you call the variable pool. This can be called anything you want actually, but you call it a pool. We've seen it with drain pool, and or in some examples we've seen already. But NS is interesting because this is from the Coca development. So NS, next step, auto-release pool, which is an object instance that we're creating. So the instance of the object, or the pointer to the reference of the object, is pool. And it's going to be equal to, well, this is the same data type, NS auto-release alloc initialize. So we create an instance of this object, and we're going to call it a pool. It's going to be an auto-release pool. What's that going to do? It's going to automatically catch up all of the things we're allocing, and then automatically release them all. So we don't have to go auto-release, 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 auto-release for each and every single one of them. Yeah, we create a pool. And we put all the objects in the pool and they go swimming. And then we drain the pool and it gets rid of them. So when Coca is used used when the auto-release pool is created automatically, then the programmer doesn't need to do it. It's not created, well, when Coca is used when the auto-release pool is created automatically, well, If you do it, you can create it automatically, or you can actually leave this line out. Most of our examples are going to have it in there. Probably in the future, if Xcode keeps going the same direction it's going in, we're not going to have to do anything about memory in the future. So, okay, so to release the pool and all of the objects in it, we go a pool release. So we're running a release method on the pool. This is the pool object. Because it all comes from NS object, there is alloc, there's init, and there's release, there's retain. We can retain the pool if we wanted to. Why would we want to? I don't know. But all the same methods work. So, yes?
Okay. Instead of using that allo, if we retain it works the same.
If you leave this out with the newest version of Xcode, I still believe it works fine without it. Yeah.
Because we said like retain or allocate means both are same, means instead of allo if you and put a retain there, it do same.
Yeah. So we don't have to do, we put this at the beginning of the code, put this at the end of the code, and put all of our object references in between. Yeah.
Instead of writing
allo,
if you write there retain.
here, you have to do alloc to create the object. This is initializing the object.
But retain and allo both are doing the same thing.
Correct, actually. But the syntax uses alloc to allocate it. Allocate will actually take and create the reference for the pointer. So this actually returns a memory address, and the memory address is given to pool. I don't believe retain returns the memory address, but it does the same thing. You're correct. It leaves it in memory. Or we'll create it if it's not there. Constructors, as we've seen so far, we can put all the allocs in the constructors. This is a class method that allocates and initializes an object. We have actually seen it. I've been calling it an initializer. We don't have to use an initializer for it. We can actually just create a constructor and call it a constructor. So in Objective-C, it's really just a name constructor that we're putting on it. We don't have the same automated behavior that we do have in Java and C++. So the programmer is neither doing an alloc nor an init with this. So what are we doing here? This is our constructor, and we're saying student with name, and then because we're going to create a student with name, and we have an NS string for the name. We have using a pointer type because it's an object, and then we have and GPA, and we're using a float no pointer because it's a built-in data type GPA, and then we have a generic type ID, which is equal to a new instructor or new instance. Actually, it's probably short for that. Equals, and then this is interesting, self alloc. Allocate myself because I'm a class method actually. And on this, we're going to initialize student with the name and GPA. So we're going to run an init student, which is the initializer. So we're using a constructor to run an initializer essentially, and initialize it with the name and the GPA, and then return the new instructor. Then we have auto release in here. So it's going to auto release it because it's a reference pointer that we created. So we're going to run auto release on it. So it's just a sample of what you can do in terms of creating the constructor. And you basically would call the method would create the new instance of the new object and run alloc on it and then release it when it didn't need it anymore. Auto release it. So essentially the method sends alloc to self, which is the student class object. Because if you remember, self is the object referenced. So essentially the method of auto-releasing the instance because it returns a pointer to the created instance. Non-essential, this example uses an existing initializer. Remember I said I called this one an init student. So it's using why don't you just call the initializer? Because it's just a method calling an initializer that we're calling a constructor. So you can design it with just the initializer if you wanted to. So you could use something else or initialize the student data directly using the initializer. So most people would actually just use initializers. So we know this is an initializer because it starts out with NI and INIT, which is one of the requirements. So when we run init student, we send it name and age. We've created it. Same thing as a constructor usually, in terms of what it is. So calling the constructor, here it is here. where we have the generic data type. I'm going to call it student, a stud, equals student, and then here's the name of the constructor that we're calling, or the method, and we're sending the method these two parameters. And inside of this constructor, it's going to run the initializer, because the initializer is inside of the constructor here. So it's kind of a way of automating it, kind of, using a constructor instead. So the message is sent to the student class object and returns a pointer to it, and the pointer is assigned to student, or stud, which is going to be a pointer value. So the calling code does neither an alloc nor an init. So this is what I'm talking about. So this is out in the main program. This is essentially, what you're looking at. But all of the inits and the alloc and everything is embedded inside of the class. So the object itself is doing its own allocation. So out in main, you might see programs that, I'm not using alloc. I thought you said you had to use alloc and you had to use init, you had to do all this other stuff. Well, we don't see, we made a new instance of an object here, of student, and we assigned it to a stud. But we didn't use anything like alloc or retain or auto-release or anything in here. This gets confusing to new students when they look at source codes examples and they go, "What, do we always have to do that?" If you want to make your life easy, you can actually write the entire program in C, actually, and call objects that are written in Objective-C that are doing all this stuff. It depends on your programming style. Depends on your objective, actually, as well. But actually, you don't even have to do the whole thing. You can write part of it in Objective-C and C at the same time. So the calling code is nothing. So the auto-release pool must be in place. Yeah. Something to note, if you can program for either the iPhone or the iPad or both of the latest Xcode, actually. So this is actually happened a couple of versions ago. It used to be that you had to install something for iPhone and iPad. Now it's all generic. Now you actually just, everyone has seen it, I hope by now, but you just select on the left-hand panel whether you want Cocoa or Cocoa Touch, and you go back and forth. And the development style is the same, actually. The XIB files are the same, everything's the same, which is kind of interesting. So you're just developing a desktop application with a window, and you're inheriting from NS application. And you're using Windows and application, which we're going to get into a little bit later, probably another week, maybe even as soon as next week. But the style of the GUI is a little bit different, but the programming is identical. So you can take existing Cocoa programs and turn them into Cocoa Touch programs kind of easily, if you can imagine the possibilities. So, or back and forth. So it makes for a really nice cross-platform development, actually. So a little advantage, well, Java could sort of work the same way, I guess. I was going to say a little advantage you don't get on the Android route, but Java, you can write programs in Java. Harder to convert those programs, though, from Java to Android. Not impossible, but definitely a lot harder, because you have the XML interface for the GUI, so all that stuff is a little different. So simultaneously be aware that there are two sets of .h's and .m's, one for each class actually that you're using. So let's take a look at the framework a little bit. So we have the UI kit framework for development, standard iOS GUIs, buttons and everything. So that's when we import UI kit. So it's really Cocoa with Cocoa Touch kit, UI kit. Well, actually I shouldn't say this, two separate libraries. The UI kit framework is going to give us the utilities for iOS. UI text field, UI font, UI view. These are going to be all part of UI kit. So the UI button, the clickable buttons, a string of text on a screen for UI label. If you've taken the iPhone class, that looks very familiar too at this point. UI buttons, UI labels and stuff. Why do they keep having the UI in there? Don't know. But if you're doing GUI development for non-iOS, it's actually the same. It's just not coming from UI kit. It's coming from NS. And this particular is for iOS, and just giving you, if you haven't seen it yet, because you're in the Objective-C course, and some of you have actually taken the iPhone course simultaneously, but if you haven't taken it, or took it in the past and you need a refresher, this is basically giving you the framework details and the event-driven behavior, which is the same construct that you're working with in a non-iPhone development environment. But most people take Objective-C programming to learn how to develop on iOS, because that's where all the applications are built. Nobody is really interested in seeing your Mac application, usually. Well, some people are. Most people are looking at the iPhone, iPads, tablets, and stuff like that. They're not focusing on the Mac. So, all right. So if you were focusing on the iOS, which is the stripped down version defined by UIKit, which is a subset of everything that's available, you're looking at the event-driven framework. So we have the interface design or interface builder. Interface builder uses the interface designer. Has some extra macros for the code that can act like hooks to variables. You have IB actions and IB outlets, as we've seen so far, actually. Not in any of the programs we've seen for this class, because we've been so far just focusing on command line. But when we get in, we'll see, well, we have actions and outlets. The same concept exists, whether you're programming on the Mac or if you're programming on iOS. So the action itself triggers events like mouse clicks, and the outlet captures outputs from events. So you write to an output, you read from an output. It's almost like there's two parts instead of one part of the event. And the action is kind of like on the Java environment, actually. When you put action listeners on buttons and things in your GUIs, if you're using Swing or AWT, same concept. But it's not per item that you're putting on top of the item, it's the item, which is kind of interesting. So rather than like creating a button and then putting an action on the button, you're just saying, well, this is an IB action that's coming from the button. And I've put the button on the canvas, and I've dragged it over, and I've linked it to the code, and here's the action. So it's a little bit clearer, I think, actually, in terms of the event-driven behavior. These are tags. They're not compiled. They don't affect the code, but they say as extra before the variables that our interface designer can use and see them. So iPhone sample projects. Okay, we don't need that. And the end of it, we finally finished that lecture. So, all right. If you're following the slide sets, we've actually covered lecture number 2, because lecture number 2 is part of that big one. So I just wanted to bring that up just to show, to basically let you know we're farther ahead than we think we are at this point. Lecture number 3. Did I cover initializers in this class? Did I cover writing initializers? I think I did. Yeah. Okay. Does this look vaguely familiar? Let's see. Casting. Yeah, I think I did this in this class. No. The problem is that like both classes are running simultaneously. I don't know if I did this. Did not do that for this class? No. Okay, let's do it for this class.
Because I was in last semester in iPhone, it is the same almost slide, so I do remember like.
Yeah.
So
well, I moved them around. I moved them around because the same concepts actually apply to both classes. But so I'm trying to give like a balance between the two of them, because not everybody's taking both of them. So I couldn't remember if I had given this already. Okay, so this plays in well then with the topics I'm discussing today, because we looked at the constructor and we looked at the initializer that was inside of the constructor. So what I'm going to lecture on right now is the concept of the initializer. The initializer is the constructor. And if you think about the definition of a constructor, it's the automatic execution of something when the instance of the object is created. And in C++ we call it a constructor, in Java we call it a constructor. In Objective-C we call it an initializer. Although we can use constructor type terminology with it, we don't really have constructors, we have initializers. So the initializer, the correct initializer must comply with the following. In other languages, we put a method inside of the class that has the same name as the class, and then that method gets invoked automatically. And the method that doesn't take on any parameters ends up being the default constructor, and we have all those different rules of how the constructors trigger with each initialization of each object from the hierarchy and all that stuff. Same thing happens here, except for we designate with different terminology and we use different wording. So the name of the method doesn't match the class name anymore. If you put a method inside that's matching the same, you're going to get an error message, actually. Actually, it may not. It may not. Depending upon if you're using the same case. It is case sensitive. So. Initializers names must begin with init. So we're going to put init at the beginning. So we write any method we want. Usually people will put, init with first and last name, init with age, init with ID, init with, it's descriptive. So we know, we can remember what we're initializing, because we're going to basically mention the parameters that we're passing. So initializers return the initialized object self. So you can use the initializer, as we saw in the previous example, to allocate the memory, to create the object, to set the base parameters for the data members that belong in the class, which is what initializers are really good for. That way you don't never have to put any allocs or anything in the main program. Initializer calls the initializer of the superclass. So the first line of the initializer is always super init. Or it's basically going to be, that's not, well, I'll go through the syntax in a few minutes, but first thing it's got to do is the same thing as putting the word super in Java, where it said go back up, go back up. So instead of this we have self, and we self and super, same concept. So initializer calls the initializer of the superclass. It will propagate up the chain of inheritance until we finally the init of the NS object is actually called. So NS object is the highest level in the hierarchy, and the initializer uses the return value of the superclasses in it. So because it's basically going to start with the present and go back up, and then it's finally going to return from the superclass, which is NS object. So the initializer must consider and correctly handle construction errors, which is kind of interesting. So we had the method syntax that's associated with it. So the definition is preceded by the plus or the minus, and the return type as a C-cast. So float as an example, result, minus, for instance method. If the method has no parameters definition, and the definition and the call consists only of the method name. And then each one of the parameters is presented by the colon, as we've seen before. Same thing as a regular method, actually. Followed by the parameter type, as in the CCAS, followed by the parameter name. So method 1, colon, integer, parameter 1. Same syntax, which is a little review of it. The more times I give it to you, the more it will stick, hopefully. So before each one of the colons, one can put a label. So usually we go and something. First name, colon, I got that syntax, and then the next one is going to be called and B, and C, and D, and E, and F. It's just an optional name. You don't have to put the name in there. But most of the examples, most people will actually put the name in there. So before each one of the colons, you can put the label. This is the label here. And the labels become part of the method name, actually, when you put the label in there. Compared to the two definitions below, these are the two identical ones. So we have float sum A, B, C, or we have float sum of A and B and C. These both do the same thing. This one's putting labels in, this one's leaving the labels out. This one's easier to read, some say. Some of my examples have it this way, some of them have it this way. Or they'll go A, and then they'll go and B and C. And leave A blank, no label. So, what happened to the attendance list? Are they back there somewhere? Okay, good. Very good. No, I just noticed they were missing on the front. Usually they're sitting up front. Now they're floating in the back, I see. They've made it their way back. Okay, here's some more examples where we have...
I think no one will pull the...
I'm sorry?
No one will release the attendance sheet. I think it won't go out of order, I guess.
I hope not.
No one will drain it.
No one will drain the attendance pool. Auto pool attendance. Attendance drain. Attendance release. At least I know someone's paying attention. That's good. Alright, so let's get back to this. So here's a definition, an example of the usage here. This is the name of the object, object 1, sum 1.1, 2.2, 2.3. This is the same thing as we've seen before. It's just another reiteration of it. This is the method itself, and the method itself is returning A plus B plus C. And it's taking on some A, B, C. So it takes 3 numbers as parameters and returns 3 numbers, and the numbers are type float. You can leave them back there. You can leave them back there. Or you can put them up here. Technically, they're supposed to be right here. Sum of A, sum of B, and C and D. Same example as before. If you're going to use this, you have to do this. You can't switch and you can't mix and match the syntax around. So this is going to basically tell you have to go sum of A, sum of B, sum of C when you use it. So the two methods do the same thing, but the second method reads much easier. I actually prefer the first method better. I don't like the labels. I will do things this way because although this reads a little bit better, it's clunky and it's more typing and I don't like to type. So read the detailed explanations in the lecture notes. Okay, yeah, I've actually already covered this. So I had another lecture that had more information on it. So in the first, actually that was lecture number 1. So initializers are arguments with arguments. And here's an example from the hello world. Init with number. So we have the word init in here, which means it's an initializer. And it's going to say with number n and value v. So number n is going to be equal to number, and value is going to be equal to v, and then return self. So the biggest difference in the return self at the end and the return type of the ID. So the return type here is ID, which is generic. So this is called the dynamic typing, if we haven't seen this already. We've seen dynamic typing in here, I think, haven't we? Yeah. I talked about ID, I believe, a couple weeks ago. Yeah. It's referred to as dynamic typing. The ID is the same as the void asterisk in C. So then we can write it as ID HW is equal to, or homework, is equal to hello world alloc, and then initialize with number 3 and value 3.7. This here is instead of init. So the first example I gave you when we started the lecture today was hello world pointer P. So I used a hello world type. And I used a P for the pointer. You don't actually have to use a pointer with a generic type. It's a generic reference, so it's not really even a pointer at that point. Equals hello world alloc, and then it had init in here, and then this was closed off with the brackets. So that was calling the NS object initializer. Generic, just creates the new initialization. If you write an initializer, as what we did in this particular example, and this particular example took on 2 values, then we can run it in here. So you might see something like this. You can take this out and put the word init in here, and it does the same thing. But it doesn't give you the values of number 3, and with number is 3 and the value is 3.7. So if you want to pass the information in, this is how you're going to do it. You're going to write your own initializer. This will still run init of superobject. It goes backwards, as mentioned before. So this will run the superobject automatically. Because when you create an instance of an object anywhere in the hierarchy, everything before it, all the way up to NSObject gets created. Same concept as in Java. Initializer is much better, but still not totally correct because we didn't call super in here. So, oops, up here. So let's see. Here we go. This is the more correct way of doing it. Instead of assuming that NSObject is actually going to be initialized, it won't be until we actually put it in the initializer. So when we write it correctly, the NSObject does get initialized. So instead of putting init out here, what we've essentially done is created another method, but we can't run both at the same time. So we run init inside of this method, and the init's going to be on super. So we're creating the NSObject, the super objects in it. We're calling it specifically equivalent to saying super inside of the constructor in Java. When we put super as the first line, and it went up and ran super. Well, just runs the constructor of the previous class. So here we have the same as before, except for we have this other line of code in here, and we have references now in here. References to self. This is being not. This is the exclamation point is another thing for not. So if it's not, if it comes back, and if it's not, like, then return. Else, then which is an assumed else in this point because we don't have to actually put it in there. We're just doing the test on if. If it comes back, then return nil, which means there's no object. If we don't get an object, which means that we ran out of memory. This actually would never fail unless we ran out of memory, or we had some sort of weird scenario going on where the memory was like very low or something. So self is going to be equal to super init, which means create an object reference self, and it is a reference actually. So run super run init, the initializer of super. Well, super is going to be NS object in this particular case because we don't have anything else in the hierarchy. So return it to self. So then if self comes back, nope, it comes back false, negative, not acceptable, no memory. Because this is going to return an address. If it doesn't come back with an address, it means we didn't allocate the object, which means return nil. Else you have self, and this is the equivalent notation for the dot, but this is for a pointer. So this is pointer notation. It comes from C, actually. We saw that actually in the C lecture. It's the symbol that is equivalent to a dot. So self dot, or this symbol here, a number, it's going to be n. So this is the same code as before, return self. The other one returned self as well, although we didn't have any self in here. We didn't actually have to create self. We created self by initializing super explicitly. If we don't, we still get self. Every time we make an object, we have self, whether or not we create it like this or not. So some people think that they have to do this, excuse me, in order to have the object. No, you'll still get self. So here's a new class. What do we got here in this example? We have interface student, and it's inherited by NS object, and we have name and GPA, and then we have init. Well, that's going to be the initializer, default constructor, or initializer. And init student, well, that's another one. So just the same way as in Java, where you can have multiple constructors, or you can have multiple initializers in Objective-C. So init student, which is going to take on an NS string name, GPA float. So. And then on the implementation of this, the default constructor, or initializer. So the same word used in the constructors, just substitute it with initializer. So we have default initializer, and that's going to be the one that doesn't take on any parameters, and this is the code we saw before. Very similar. It's just initializing two different variables.
So we don't have to create default initializers normally.
You don't have to do it. You don't have to do any of this stuff. Just the same way as you never have to create a constructor in Java. I can get away without creating a lot of. No, you have to create some constructors. Yeah. It's just the same way as eventually you'll have to do. If you're doing inheritance, you'll have to super init eventually. Because you'll get to a certain point where the objects can't be created because they're missing initializers. And it also helps to automate the creation of the objects. So rather than running methods on each one of these objects, just run the initializer when the object gets created. And you can automatically set all the default values for the variables. Okay, so here's init student with the implementation of the initializer that takes on the two parameters, the name and the GPA. And same code, essentially. Same code as before, but instead of setting it to nil and 0, it's actually putting the values from the parameter lines and adding those values in there. So, alright, so that was the initializers. The other lecture we needed to cover today was very short, extremely short lecture, which is good. We have about a half hour or so left, at the most. Lecture number 4. We've hit most of these concepts, but we actually haven't defined the terms yet. So derivation and runtime binding. So derivation and runtime binding are most essential parts of object-oriented languages. As I mentioned before, everything in Objective-C is dynamic, which means it's bound at runtime. So there's no static binding. What is binding? Well, binding is the association of the memory with the reference to it. So if we do it on the fly, and actually if you want to see something really interesting, you can watch the video from the iPhone class today. We're going to do dynamic GUI binding. So we'll create some objects, some labels and things, and then while the program is running, we'll change the attributes with the labels. And we'll change stuff because it really doesn't get created until it's running. Everything's dynamic, so we don't have to set anything. We just put a label out there, and we can run a program that changes the label and changes the background color, does everything we want to dynamically, which is referencing objects that are created, but we're doing them as the object after the object is created, and then after the program is running, and it's happening while we're clicking and stuff, which is actually kind of interesting. But it demonstrates dynamic binding. So both classes really are working in sync. So anyway. Which is good for people who are taking both classes together. Alright, so the derivation in terms of inheritance. Derivation is the systematic mechanism for inheritance. We derive one class from another class. So dynamically, when the object is out there, when we create an instance of an object, we actually dynamically create all of the other instances in the hierarchy when we're using them. We don't actually have to create them unless we're going to use them, which is a little bit different than languages that do static binding and compile time binding, or compile time everything. So in Java, you have the instance whether you want it or not, but you have automatic garbage collection by the JVM. So when you make a student, you get a student, a person, and an object, or anything else that was in the hierarchy. In Objective-C, you don't actually need it. So you don't have to actually initialize, you don't have to actually use it. You're just going to use whatever objects, and you can have, this is where this ID comes from. It's a generic object. If you don't know what object you're going to assign to it, you use ID. And ID says, oh, we're just going to have an object. It's just a placeholder. And eventually we're going to substitute in with the object we're going to have in the hierarchy that we're going to create and we're going to assign to this ID. So it's kind of a cheat way of, not cheat way, it's kind of a streamlined way of creating the object without having to decide, because it's not necessarily going to be built for you unless you use it. But if you declare it as a particular type, you're going to make the type. So you're going to make a student, or you're going to make it, instead of deciding at runtime what you're going to make. So inheritance is a systematic of derivations. It expresses the meaning of the derivation. The derivation is deriving this object from this object from this object from this object in terms of its placement in the hierarchy. Derivation is a mechanism by which a class acquires the methods and the instance variables of another class. It's derived from, also called its superclass, which is really the definition of inheritance if you think about it. A person derives all of its information from object, or a student derives all of its information from person, or employee, or whatever, wherever it came from. So here's inheritance in Objective-C, the initializers under the inheritance. So inheritance is expressed in the new class's instance declaration. So we have interface grad student that comes from student. We have additional instance variables in here, and a student major, and a string, which is going to be a string object major. And then we have a list of inherited methods to override if we're going to override something. And we know that hopefully at this point we haven't looked at it yet, but what's coming up, probably Monday actually, is going to be, because I'm going to run out of time today, is overriding and overloading methods. So when we inherit, we've seen inheritance, but we really haven't seen very much overriding and overloading yet. But and we also haven't seen a lot of other things. But long story short, that would go in here as well. And then we have the initializer here, initialize grad students, which is going to be the initializer for here. So the initializers go inside of each one of the objects. When the object is created, the object itself knows how to initialize itself, which makes it a little bit better for the dynamic allocation of the object, dynamic creation of the object. So the initializer, from an object-oriented perspective, is kind of like the constructor in the Java, is the equivalent to the constructor in the Java perspective. Meaning you never want to have variables that don't have any values associated with them. So what you're supposed to do in the default constructor or any default initializer is assign values to those variables. Because in here it's especially important because we can be out in the runtime environment and everything's allocated dynamically, and we don't have a person, but we have an employee. Well, how are we going to initialize anything? So the initializing is kind of sets everything. So it ensures the integrity of the object, I guess, in some ways. Then we have what's called runtime binding. So it's the decision during runtime which method to execute when a message is sent to an object. This gives us polymorphism as well. And it's the same thing we get with Java as well, and C++. Except the methods themselves are run, everything is bound during runtime. It's not preset. So, which means we can inherit and then we can override and overload, which is explaining the same concept that we saw in Java, actually. So executed methods depend on the type of the object that we have. So we have different names, or we have the same name, the same method. We have it in different types of objects. We dynamically change from a person to an employee when we run the print object, which is what you're going to do in one of the assignments, actually. You have a print method that's going to be inside of all these different objects. And all the objects may or may not be running simultaneously. And then when he switches to an object of this type, then go ahead and run the print method that's associated with that type. So, which gives us polymorphic type of behavior. The message can be sent through the typeless pointer ID as well. So if it's an object of a person and it's assigned to an ID and we run print, well, it's going to take whatever it was dynamically allocated for that object and run that print method. So it's kind of interesting, actually, in that terms. So, okay, it looks like we're going to end a little early today, which is nice because I can hold you till, I've been holding you till 7 every time. So we are on schedule and we finished everything we need to finish. So next week we move on to bigger and better things. Overriding, overloading, some more initializers. So I'm trying to run this like every other PowerPoint versus examples. So bring your computers on Monday, and Mondays will be all about source code examples. And I'll have, during the weekend, I'm going to upload a bunch of new examples because I'm trying to revamp the whole thing for Xcode, for the current version of Xcode and all the changes that have been made. So for automatic reference counting and stuff like that. So all my old examples are kind of outdated at this point. So anyway, as I revamp, I'm repopulating the behacker.com website. So by Monday, I'll have the new examples for you, and we'll do that on Monday. So, all right. Have a good, enjoy your extra half hour.